Last topic of Algebra Basics, simplifying algebraic fractions. So that just means fractions that might have variables in the top or the bottom. They're also called rational expressions. I'm just trying to keep the lingo as straightforward as possible. So for this course, it's kind of, sometimes you feel like you're breaking things apart when we were simplifying by division. But when we are simplifying algebraic fractions, basically we're taking any number of fractions, and there could be a list of other terms as well, and we're making them into a single fraction. So there will be operations on top, plus, minus, all that kind of stuff, but we want everything over one denominator. And we know how to do this because we used to do this with plain old numeric fractions. So let's review what we do for numeric fractions. So we had, in the last slideshow, found out that the lowest common denominator of the numbers 30, 12, and 15 is 60. So what I want to do is I want to change this into something over 60 plus something over 60 minus something over 60. So that will be my 13, my 5, and my 7 will change. And when we do that, we use what I sometimes call, not consistently, the action fraction. So the action fraction will be the same on the top and the bottom, and it's whatever you are going to use to turn that 30 into a 60. It'll be a multiplication thing. So just old school, remembering that if I had 1/2 and I wanted to change it into something over 6, I would multiply by an action fraction that is the same on the top of the bottom. So all the math I'm looking at here is how to change the denominator. So whatever I multiply the denominator of my original fraction by, I'm also going to multiply the numerator by that same number. And guess what 3 over 3 is? It's 1. So all these action fractions are just different ways of saying the number 1. And what that does, top times top, bottom times bottom, is creates an equivalent fraction, which is 3 over 6. So 3 over 6 is the same thing as 1 over 2. You know that. If you needed to check, you used to divide the numerator by the denominator, and you would end up getting the same decimal. So they are equivalent fractions. So I just want to make 3 equivalent fractions over 60 and then combine them. So back up to the top, I need to multiply 30 by something to make 60. 30 times 2 is 60. If I multiply the 30, I must multiply the 13 to keep the value the same. 5 over 12. 12 times 5 is 60. So I just do this, multiply the same thing top and bottom. Looking at the 15, how do I make that into 60? What's missing? The factor 4. 15 times 4, 7 times 4. So when I go to my statement here, I end up with 26, that's 13 times 2, 25, 5 times 5, minus 28, minus 7, or 7 times 4. And once, with fractions, what you're allowed to do, if the bottoms are all the same, you can put the numerators all over a single denominator. And when we're talking about numeric fractions, usually that means you can do all the math. So 26 plus 25 minus 28 gives us 23 over 60. So yes, we've solved this in numeric fraction. Yes, it could be considered an answer, but it's a simplification too. So let's do one more from the very, very start. And you notice I've kind of spread these fractions out. That's because I don't like to rewrite as many times, so I always try and sneak my action fractions into the original statement. You do you. So I need to find a common denominator for 8, 24, and 18. So let's look at 8. The prime factorization, 2 times 2 times 2. Try and make that a little clearer. And then 24 is 8 times 3, so that's 2 times 2 times 2 times 3. And if you need to review this, back you go to Algebra 3. And 18 is 6 times 3, which is 2 times 3 times 3. So once again, what do I have? I have 2's and I have 3's. Where do I have the most of both of them? Well, in 8 and 24, they both have 3. And for the 3's and 18, I have 2. So my powers will be the count to the power of 3 multiplied by 3 to the power of 2. And that's what will give me my LCD, which is going to be 72. So my next step over here, going back to, let's go blue. I'm going to make it something over 72 minus something over 72 plus something over 72. To turn 8 into 72, I need to multiply by 9, do the same to the top. To change 24 into 72, probably 3, same to the top. And to change 18 into 72, multiply by 4, same to the top. So I end up with 27, because that's 3 times 9, minus 3, plus 20. And that's just doing the math here, here, and here. Everything can go over one denominator now. And when I do that math, I end up with 44 over 72, which is correct, but both of these numbers are divisible by 4, so kind of doing the opposite. We were going up to find a lowest common denominator and multiplying, but when we're reducing, it's like we're dividing. So I'm going to divide top and bottom by 4 to reduce a fraction, and I end up with 11 over 18, and I cannot reduce that anymore. So now we're going to switch it up, and we're going to throw some variables in. LCD, lowest common denominator. I see a number, 3. I see a plain old x, and this 2 is tied up. So I can't break it and say there's also a number 2 or there's a loose number 1. This is my third factor. So my LCD just becomes smash those together. 3x, 2x plus 1. Okay, so now we're going to look at what is missing from each one. So the first fraction has a 3x already, but it doesn't have the 2x plus 1. So I'm going to multiply the denominator by 2x plus 1 to turn it into my LCD. If I do that to the bottom, I have to do that to the top. Alright, I'm going to do the same here. Get some brackets to represent multiplication. This one already has 2x plus 1, but it is missing the 3x. Excellent. Okay. I'm going to have, and this is just 1 times 2x plus 1. Now resist the urge to cancel things out. That's not why we're doing this. We made this fraction so that we could add it to the other fraction. And do that math. 2 times 3x is 6x. And on the bottom, we get the same denominator. Okay. And then we can put this all over 1 denominator. And I guess I'll write it out. There we go. And now your last step is to just make sure that you can't combine anything. Do you see any like terms that you can collect? Yeah, 2x and 6x can combine, and my final simplified answer is going to be 8x plus 1 over 3x onto 2x plus 1. Alright, you don't have to distribute the 3x in. Pay attention to what the test is asking you. If it asks you to leave the denominator factored, or if it asks you to incorporate it, and just do what they tell you to. But for me, this is perfectly fine. So we're going to do another practice, and we had previously done the LCD for this. We'll do it again. So what do we see? Just starting with numbers always, I see 2, I see an x, and of the same kind of thing, I see an x squared, and then I see its own special piece, x plus 7. So to make our LCD, the number we need, the x to the highest power it shows up, square, is higher than the 1, and then the binomial. So up we go. Oops, that's 7. Just kind of getting ready. That one doesn't need that so much. To multiply. If we have x plus 7 already, we are missing 2x squared. In this one, we have x squared, but we don't have a 2, and we don't have the x plus 7. So that's what we're going to multiply by. And we're going to have some FOIL going on in a second here. And in the last one we have 2x, that's great, but I need 2x squared, so I added another x, and I also don't have that binomial yet. Okay. So as we go through now, lots of simplification. So initially I'm just going to write out what I can, and I'm going to put them onto the same fraction. So 4 times 2, 8x squared. This one I'm just going to rearrange a bit, or I'll incorporate that 2 maybe, and do this. Distribute the 2 to the x and to the plus 7. Okay, and then going over here, okay, it's going to be 3 times x plus 7, so basically 3x times x plus 7. So that's going to give me 3x squared plus 21. Okay, so I could put LCD, LCD, LCD. I'm just going to recognize right now, ooh, that I cannot draw a straight line. And this is all going to be over 2x squared on 2x plus 7. All right, some more work. Getting a little nervous that I'm going to run out of room. And that happens all the time. So I'm going to do the FOIL here. So first is 2x squared. That's the first. And then outside is 14x. Inside is 6x. And last looks like it's going to be 14 times 3, which is 42. And then my 3x squared plus 21. That's all. Getting really lazy here for space. Over your LCD. And now gather your like terms. So I have 3 things that have x squared in them. So 8 plus 2 plus 3. 13x squared. I have 14 plus 6 for the x's plus 20x. And then I have 42 plus, oh, I just realized I made a mistake. When I distributed the 3x, I forgot to put this on. So I caught myself that time. Doesn't always happen. I definitely make mistakes. Definitely email me if you find a mistake in this. So I'm just going to erase that 20x. That term is going to change. Okay, so we had 14 plus 6 is 20, and now we're going to add that 21 in and get 21x, and we just had the plain 42. And then we're going to put that bad Larry, 2x squared, x plus 7. And once again, you don't have to bring that in. I'm just going to try and highlight this as my answer. This is my final answer. So draw a box around it or highlight it if you're handing your rough work. That's what I would expect to see for that one. And we're not factoring, so don't be a hero and try and factor that. Just collect any like terms you can. Definitely, if there's binomials that you can expand, do it. But this is good. This is our final answer. Number 2. LCD. There's an x and there's an x minus 1. Two different things, so our LCD will contain both of them. What's missing from this one? X. What's missing from this one? X minus 1. Okay, so distributing that x, hopefully this time to everything, x cubed plus 4x squared. I'm going to leave the minus sign and we're going to bracket, because this minus sign means that everything is subtracted, so I call them the prophylactic brackets. So you just put them on until you don't make sure that you don't need them anymore, and right now I do actually need them. So I'm going to do FOIL in here. First, 2x squared. Outside, negative 2x. Inside, negative 7x, which I hopefully makes negative 9x. So just kind of ramping things up a bit. And then last, negative 7 times negative 1 should give me positive 7. And that's all over x onto x minus 1. Okay. There's a distribution that has to happen before I can do this, because it's like you have a little invisible negative 1. So remember, you're distributing that negative 1 to everything in the brackets before you're allowed to get rid of the brackets. And here we go, and it will just change the sign of everything. Negative 2x squared plus 9x minus 7 over the LCD. And just so I have enough room, we're going to gather any terms we can. X cubed has no one to go with. 4 minus 2 for the x squared will give me positive 2x squared. 9x is on its own. And 7 is on its own. That will all be over x onto x minus 1. And you're done. That disgusting mess is what I wanted. There's your answer. In in yellow. Example 3. So I see a lot of people trying to make this somehow, the LCD with this. X minus 1 and 2x minus 1 are different things. Do the number test. If x was 10, x minus 1 would be 9. 2x minus 1 would be 2 times 10, 20 minus 1, 19. That's not the same thing. So these are not the same. So that's not your LCD. Your LCD is just what it is. Can't make it better. And don't expand this. Use it to multiply. Otherwise you're going to get a really big thing going on that you don't need to be that large. Okay. Missing 2x minus 1. Bring it in top and bottom. Missing x minus 1. Multiply it in top and bottom. So just putting that there so you get that it's binomial. And here we go. 4x squared for the first. The outside is negative 2x. The inside is negative 6x. So these kind of ones, you can always kind of do them in one step if you're comfortable and combine them. So negative 2 and negative 6, unless you're going to talk too much and forget what you were just doing. And the last is negative 3 times negative 1. Gives me this. Let's keep up the habit of using the prophylactic brackets with the plus sign in front. I won't need them, but just in case. First, 2x squared. And then outside negative 2, inside negative 7, minus 9x. And then last, negative 7 times negative 1 plus 7. Woo! This like line drawing is killing me. And that's over x minus 1. 2x minus 1. Okay, and then let's combine. 4 plus 2, 6x squared. Negative 8, negative 9, minus 17x. And positive 3, positive 7, positive 10. These are tedious. They really are. But this is like the last money ticket kind of question on this test, and it requires you to know how to do your expansion and your distribution, so it's really kind of testing all your algebra basic skills. And our very last slide, we got some numbers. So our numbers are 3 and 15, and they will both fit into 15, so no like big thinking required on this one. And I see an x plus 2, which is different than an x minus 1. Sorry, that's an x minus 1, or I don't even know what that is. So our LCD is going to have the number 15 in it, this binomial, and this binomial. Okay, here we go. Find what's missing. Our first fraction is missing. Well, the number is 3. That's not big enough. So I have to change the number from 3 to 15. So I need to multiply that 3 by 5. And I've got an x plus 2, but I don't have an x minus 1. And whatever you do to the bottom, you do to the top. Ooh, this one has the 2 binomials. Just trying to fit these in without writing over it. But it doesn't have the number 15. So in that goes. And our third one has a number and none of the binomials. So we're going to add those in. I keep saying add them in, I mean multiply them in. Okay, here we go. So I'm actually, oh, I can't even look at this. Going to do this my way, which is a little different, and I'm going to throw the 5 in the front, and you could do the 5 in and distribute, that's fine, and just deal with the binomials. So 2x times x, 2x squared, and then 2x times negative 1 minus 2x plus 1 is minus x, and then positive 1 times negative 1. So this will be a several step thing. The second one's just kind of distribution, so 15x, oh, but I've got to keep the bracket on, so because signs will change, minus 105, 7 times 15. Oh. And the third one, doing the binomial expansion, x squared, outside is minus x, inside is plus 2x, so I'm going to get positive 1x, which you can just write as plain old x, and subtract 2. And that's all going to be over the LCD. Okay, here we go. Distributing. So what am I going to do now? I'm just going to draw my actions that I'm going to take. I'm going to distribute the 5 to these 3 things. I'm going to distribute the negative to these 2 things. And I'm going to distribute the 2 to these 3 things. And that will get rid of all the brackets, and then I can collect like terms as my last step. 10x squared minus 5x minus 5 minus 15x plus 105 negative times a negative. 2x squared plus 2x minus 4. All over the LCD. Okay, gathering. The 10 and the 2 are like terms, so I'm going to make them 12x squared by adding them. We've got 5, negative 5, another negative 15, that's negative 20. And we are going to add positive 2, so it gives me negative 18x. And in the numbers, negative 5 plus 105 makes positive 100, subtract 4 makes positive 96. And that will all be over 15 x plus 2 x minus 1. And if this was a factoring unit, I would ask you to notice that 12, 18, and 96, as well as 15, are all divisible by 3, and you could factor out the 3 and then cancel that. But because we haven't discussed factoring, that is not required at this point in time. So our final answer can look like this, or it can be a little reduced. full credit either way. That is the last topic for Algebra Basics. So if you've gone through these 4 slideshows, you should have everything you need to write the test. The classes will be review with the MyLab math type questions, so you get used to the style of questions on the test, and then we're off to the races and on to factoring next.